Let's move on to Geometry 4.2, Congruent Figures. Your vocabulary list for Lesson 2 is much shorter than Lesson 1. We'll be talking about congruent circles, polygons, and triangles. We have 3 theorems. We also have a table of congruence properties. So, a good suggestion, just go ahead and write out this table right now. When we get to it in the lesson, you'll have it ready. So congruent circles are circles with congruent radii. For these 2 circles, circle M is congruent to circle P because the segment MN is congruent to the segment PQ. When circles have radii, the radii in the circle will all be congruent to each other. If we have a radii, let's give an example. Let's say that MN is 2. What they're saying is that the length for PQ will also be 2. We've already studied congruent segments and angles. Congruent segments have the same length. Congruent angles have the same measure. Remember that segments and angles are sets of points and are congruent, not equal. In general, though, congruent figures are figures with the same size and same shape. You can visually see that with these circles. The congruent figure can be flipped or rotated so that it fits exactly on the other congruent figure. Congruent polygons are polygons whose corresponding sides and corresponding angles are congruent. In this example, the tick marks show that for these 2 triangles, the segment AB is congruent to the segment DE, and BC is congruent to the segment EF, and segment CA is congruent to segment DF. You can see that each side has a tick mark, or 2 tick marks, or 3 tick marks to identify the congruency. Also, the angles will do the same thing. So we have angle A, which is 2 arcs, which is congruent to angle D, which is 2 arcs, and angle B, which is 3, congruent to angle E. Angle C has 1 arc, and angle F. If you have difficulty seeing that these triangles are the same, redraw the triangles. Put their congruency marks on there and relabel them to make it visually easier. The corresponding parts are indicated by the order in which the vertices are listed in the congruent statement. So this is the congruent statement. AB is congruent to DE. If we rotated triangle DEF by 180 and slid it on top of the triangle ABC, you can see the direct correspondence. So the correspondence statement would say triangle ACB is congruent to triangle DFE. The direct correspondence would be A is to D, B is to E, and C is to F, and so forth. You can say that triangle ABC is congruent to triangle DEF, but it's incorrect to say that ABC is congruent to EDF. The arcs do not line up on the drawing. Congruent triangles are triangles whose corresponding sides and corresponding angles are congruent. For figures to be congruent, their sides and angles must be congruent. The definition implies that corresponding parts of congruent triangles are congruent. This is abbreviated as CPC-TC. We will use this from now on in geometry to describe when we're using parts and making correspondence to prove equality and so forth. So CPC-TC, get that in your notes. Its corresponding parts of congruent triangles are congruent. Let's look at example 1 from your text. We have sets of triangles here. The triangles that we're going to be interested in is the triangle UVW, the smaller triangle, and the triangle YXW. So UVW will be congruent to YXW. We're asked to list all the congruent parts. This is just a personal preference, but I always list my angles and then I list my sides just to keep track. So if we have angle U on this triangle, and before I go further, if you have difficulty seeing these, remember, redraw them. But one of the clues I can give you is both of these triangles share this intersection right here with angle W. So you know that the triangle correspondence is going to show that. And actually, if you look over to your left, you'll see that the correspondence statement does show that angle VWU is congruent to XWY. There's a W in the middle of both of those angles. So angle U is congruent to angle Y. Angle V is congruent to angle X. Angle VWU is congruent to angle XWY. We also have sides that are congruent, so we have UV is congruent to YX, VW to XW, and UW to YW. When you're asked to do these problems, you need to list these sides and angles that are congruent in the same manner. If you're doing one of these problems, be careful not to just say angle W. Angle W is more than one angle. It belongs to both triangles, so you have to call it out with 3 letters. Example 2. Find the measure of angle X in example 1 if triangle UVW and triangle YXW are congruent. The measure of angle U is 22, and the measure of angle UWV is 30. So we have one small triangle with 2 angles that they've named. We have a measurement of 22 and a measurement of 30. All we have to do is solve for the third angle. So remember that all 3 of the angles of the triangle equal 180. The measure of the unknown angle, which in this case is angle V, plus 22 plus 30 is 180. And if we subtract 52 from both sides, we find that the measure of angle V equals 128. But we're not done. It says find the measure of angle X. Well, angle X is in the other triangle, so we use our correspondence statements from example 1, and we see that the measure of angle X equals the measure of angle V. That's because they're congruent to each other, so that means the measure of angle X is 128. By applying CPC-TC, we can substitute corresponding parts of triangles. Example 3. This figure to the right, you will see a lot when we're talking about triangles and triangle correspondence. Given the figure where BD and CE bisect each other, prove that triangle ABC is congruent to triangle ADE. They have a formal proof in your book, but I'm just going to do an informal proof on this. Because BD and CE bisect each other, that means that it creates equal segment lengths. If A is the midpoint of BD and CE, which is what we're told in the given, or this is what we assume from the given, then segment AC is congruent to segment AE, and segment AB is congruent to segment AD. Angle DAE and angle BAC are congruent because they're vertical angles. Angle C and angle E are congruent because of theorem 4.1.2, which said if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. In the last lesson, they failed to mention that you can abbreviate theorem 4.1.2, so I'm giving you permission right now, and you can call it angle-angle. Or sometimes, if it's an equilateral triangle, equiangular triangle, you can call it angle-angle-angle. So from now on, you're allowed to put just angle-angle to identify that the third angle is congruent. Consequently, and therefore, triangle ABC is congruent to triangle ADE, and that's the definition of congruent triangles, because we've proved the angles and we've proved the sides. So here's that table I told you to write about, and this should look familiar. Congruence properties for geometric figures x, y, and z. So we have the reflexive, symmetric, and transitive property. Their meaning: with reflexive property, x is congruent to x. Symmetric: if x is congruent to y, then y is congruent to x. And transitive: if x is congruent, y is congruent to x, and y is congruent to z, then x is congruent to z. Remember that the name for a relationship that is reflexive, symmetric, and transitive is equivalence relation. We have three theorems in lesson 4.2. Theorem 4.2.1, triangle congruence is an equivalence relation. 4.2.2, circle congruence is an equivalence relation. And 4.2.3, polygon congruence is an equivalence relation. Those should be fairly easy to remember. Let's take a look at some quadrilaterals here. By comparing the markings on these two quadrilaterals, you can make the assumption that ABCD is congruent to HIFG. If you were to flip these and also rotate them, one of them would fit on top of the other. By using the relation between triangle correspondence and polygon correspondence, you can prove that the properties of congruence also apply to polygons. We do this by doing things like drawing a diagonal and making two triangles. Lesson 4.2 homework is number 1 through 13, 17, 19 through 25, 31 through 33. I believe on your lesson plan it said Also 38, do not do 38. There is an extra credit problem at the end of the last slide. So as a few examples, number 7, write a valid triangle congruence for each pair. Pay particular attention to the markings on the diagrams. So when they're talking about writing a valid triangle congruence, they basically want you to compare the two triangles together. So for triangle, this is just another personal preference. If I have a triangle and we have these markings, I start with the angle that has the one arc. So A has 1, B has 2, C has 3. So triangle A, B, C is congruent to triangle, and now I match with the second one. P has 1, Q has 2, and L has 3 arcs. If you want to check yourself, what you can do is compare that AB, and I'm looking at the first side here. Let me show you how this is done. AB will be your first line segment. Then BC will be your second line segment, and then CA will be your third. The same thing will happen in correspondence with the second triangle. So AB should compare to PQ. And let's look at AB. It has 3 marks, yes, and PQ has 3 marks. BC with 1 mark should compare to QL with 1 mark. And it does, and you don't have to go any further because you've already compared 2 sides. The third side will be congruent. Use correct notation to name the triangle a congruent triangle. So they want us to compare between these two. So we start with triangle TIS. 2 arcs, 3 arcs, 1 arc. That will be the same as triangle DNA, 2, 3, 1. Triangle IST, 3, 1, 2, will be NAD. Triangle TSI, 2, 1, 3, will be DAN. And the last one, triangle SIT, 1, 3, 2, would be AND. Now they made it easy in this example because the triangles are lined up in exact same direction, but it isn't always that way. Number 14, name the congruent corresponding parts of the congruent triangles. So I start with angles. Angle Z, and I think I'll zoom in here. Angle Z will be congruent to angle R. Z is in between a segment of 1 and 2.5, so is R. Angle P will be congruent to angle Q, and angle L will be the last one, so that'll be congruent to angle C. And we already have the numbers, so ZP, which was a segment of 1, will be congruent to RQ. ZL, which is 2.5, will be congruent to RC, and the last segments will be congruent to each other. PL is congruent to QC. Use the figure to find each measure. What we have here are a series of triangles. We have triangle ACB. And then we have triangle ADB. So they ask us to find BD, this segment right here. And we don't know the length of BD. It's unknown to us. But by using the triangle correspondence, let's look here. BD is the same as saying DB. And I have DB right here in the triangle. So I can compare it to CB in the other triangle. And there it is. And it's 5 feet. So BD equals BC, which is 5 feet. And there's your answer. Find the value of each variable if triangle LMN is congruent to triangle PQR. MN and QR are corresponding segments. MN equals x plus 45. QR is 4x minus 30. So if they're congruent, all we have to do to solve is set them equal to each other. And I've done that. You don't have to do that yourself, but that's just to give you a visual. And we perform our algebra miracles. 4x minus 30 equals x plus 45. If you start in the other direction, it'll still work. You'll just have an extra step to get rid of your negative. 3x equals 75. X equals 25. Number 29. If there's enough information to conclude that the pair of triangles is congruent, write a valid congruent statement. If not, state any additional congruencies that are needed. Well, we don't have all the congruencies here. We do have, actually we have a set of lines here that are congruent. They're both sharing this line, so that means it has to be congruent. That's the reflexive property. And we also have two sets of segments here that are congruent. And we have one set of angles that we show. So we have to prove some other ones. Let's go ahead and prove, because we need to set up the rest of our congruency statements. So AB is congruent to CD. And you could say angle CBD is congruent to angle ADB, or you could also state that angle A is congruent to angle C. Remember, that was pretty horrible. Remember that if you set up two angles in congruency, you don't have to mention the third. If you set up two sides in the triangle, you won't have to set up the third also. The extra credit problem is here on the slide. It's pretty self-explanatory. It's not in your book, but there are 4 different things to solve. You need to solve for the variable x, and then solve for the measures of these angles. Hope that helps. Contact me if you need any further assistance. Have a blessed day.